All right, welcome everybody. This is another exciting learning lab. What we're going to be talking about today is feature engineering, but we have a special guest, and this guest is going to be Max Kuhn, who is the head of Tidymodels. He does all the development at our studio, him and his team, and they're working on massive amount of packages and software. We're going to be focusing in on one of them in particular today called the embed library, because this is really great for feature engineering. We're just excited to have him. So thank you, Max. Thanks so much for joining in.
Very happy to be here.
All right, well, let's get this thing kick-started. For those that are tuning in today, this is part 2 in our Tidymodels series. So we're going to have 5 parts to it. I'm envisioning, so if you're just joining in, 2 weeks ago, we did NLP with text recipes. Today, we're going to be focusing in on feature engineering with embed. And then in parts 3 through 5 coming soon, it's some of the newer stuff that's coming out. So there's a new Tidy-esque version of the Light GBM package, and I'm going to show how it links in with my model time package. And then part 4 will be ensembling with stacks. And we may even have some more. Max, I know in the recent RStudio talk, you talked about the racing strategies for doing, I guess it would be like the sampling and cross-validation.
Yeah, it's like a really efficient way to do grid search, especially if you have models that take quite a while.
Do you think it's ready for the prime time? Because maybe I'll have that in as a part 5.
Yeah, I like to think so. Yeah, it's been around for a while. I mean, it had been in Caret for like maybe 7 or 8 years now. So I know that the
algorithm's probably pretty good.
Yeah,
it's been tested.
Been testing it quite a bit, so I feel pretty good about it.
Sweet. Well, I'm excited. This is going to be a good one. For those of you that are unfamiliar with Learning Labs, this is a live, every couple of weeks I do a new Learning Lab, and what it does is it goes into our membership program. So we have now 49 labs on all sorts of different topics. They're basically 1-hour courses, and you get lots of valuable bonuses. Today, the big bonus is going to be an application that I developed, which is a Shiny customer segmentation and product insights app. I actually have it running here. I guess I'm calling it the Shiny Explorer. And actually, this is an older version of it. Here, let me refresh it. Yeah, this is what it looks like. You get to click in. It's kind of like Tableau. You click in and you drill in. And you've got different probability of purchases, and you've got some more information over here. I'll explain it a little bit later once we go through the demo. A couple of weeks ago, we gave away the Shiny NLP token automation app, which was with text recipes. So we're building up a nice repo of Shiny apps here in the Tidy modeling sessions. All right, so Max, I want to talk about you for a couple minutes. You are, as many in the R space know you, a Tidy modeling master. And, you know, there's probably a lot that we could talk about here, but just for those that maybe have never heard of Tidy modeling or haven't heard of you yet, you mind just introducing yourself?
Sure. So, I mentioned I work at RStudio right now. I've been there for like 4 years, I think. For like 18 years prior to that, across like 2 companies, I worked in molecular diagnostics and drug discovery, mostly doing predictive modeling and machine learning type applications. And in the process of doing that, like when I was out of graduate school, so this is like 1998, you know, within S+, and then when R came around, a usable version of R was around like 2001. You know, it kind of dawned on me that there was not a lot of, like, if you were doing modeling for your job, there was quite a few things that were missing, little things. Like if you wanted to compute like sensitivity and specificity, there weren't really functions and things like that to do that. And so I started to write a bunch of code to fill in those gaps. And then, you know, I'm a big proponent of trying a variety of different models, not just always fitting your favorite model. And so when I started at Pfizer, I had some time and blessing from the leadership to write sort of an R package that would sort of like make it easier for people who do modeling for a living in R to do that. And that was called Caret. And so Caret was around like 2005. It's used quite a bit. And that went pretty well for a while. Wrote a couple books.
Caret was huge. I know when I first started learning R, Caret was like the machine learning package and modeling package, before it was called machine learning. So that was, huge. That has an impact on so many different people.
Yeah, it solved a lot of problems. So let me put it that way. I would say that I'd had informal training in software engineering. So, the thing, I love Caret, but the thing I realized about it in hindsight was I was not prepared to, it works great, but I wasn't prepared to support an R package that was, at its height, like download like 200,000 times a month.
Yeah, right.
Right. So that's it's a lot. And it also kind of shifted to be like a little bit of a part-time job within my company. So time went on and that worked really well. And, I was using it in my job and other people were using it in their jobs. And then, around 4 years ago, I was talking to Hadley and JJ and they said, oh, we're going to get into, the Tidyverse, but with modeling. And, we wanted to see if you'd be interested in working on that. And so I said yes, not because I had any bad feelings about Caret, but it has a very 2005 R interface. And so like I said, the software engineering behind it was sort of limiting in terms of there were things that I wanted to be able to do, but we have to kind of rewrite it to do them. And so the idea of starting from scratch, working with the great user interfaces we have through the Tidyverse and ggplot and things like that, and do that full time was kind of like a no-brainer. So when I started working at our studio, we just started laying the groundwork initially for what we wanted to do.
Can you walk me through that or walk us through that process? I'm being a little selfish right now, but this is what I want to hear is kind of that transition from, working at, what was it, Pfizer to come into our studio and then having and then working on a project as prolific as the Tidymodels. How'd that go down?
Pretty well. There's a bunch of aspects of that. Working for a huge corporation, I was employee number 50 at our studio. So working
still pretty small then,
yeah. And we're not. We're 180 now, but we are a lot of we're basically a lot of individual contributors. We have absolute autonomy in what we wanted to do, basically. So that in itself is different than a huge corporation.
Mm-hmm.
And it's my feeling is this has never happened, but my feeling is that I don't want to be the smartest person in a room about something. I always want to be able to have somebody where okay, you need to, how much can you tell me about this or that? So in moving to our studio kind of felt that way where I was wow, I get to really think about how to really design software in a way that's, very sustainable, manageable, and it works well. And so there was a lot of things that, I'd sort of, in my spare time would work on, but now I have it in my full-time job. And that was a big deal. And there's all the cliches and stereotypes about moving from a massive corporation that's very hierarchical to a small company. And almost everybody at our studio, especially at that time, all of our I think all of our job titles were software engineer.
Mm-hmm.
And, coming from a corporation, everybody measures their worth by their job title. And so, there was a period of time where people did not realize how great of a thing this was. And they're are you doing okay? So it's kind of I have no idea. And these are the same people who'd be Hadley who? And they're oh yeah. So yeah, it's been a great switch. Working from home has not been bad. We're almost everybody at our studio is remote. We do have an office in Boston, but it's sort of sparsely populated.
Well, do me a favor then. Tell me about, for those that are new to Tidymodels, tell me about that. How would you kind of describe Tidymodels to a 2-year-old and then, or a 5-year-old? We'll at least say 5 as the minimum age limit. and then kind of talk about maybe like what you're working on now.
Yeah, so with Tidymodels, what we want to do is we want to make easy to use and understandable and especially predictable user interfaces for all sorts of models. So, Caret was mostly focused on like predictive modeling, machine learning. In Tidymodels, we want to do a lot more, a lot wider domain types of modeling. So that's one thing that we want to do. And, the biggest thing, about the Tidyverse, which is percolated down to us, is the thing that we think about the most. We think about like computational efficiency and things like that. But, and this is not the party line, but my sort of way I feel about the most important thing to us is we don't want you to hate R, right? So there's times when you're using base R where you're like, whoa, like what? And
that's everyone's first experiences. They want to bang their heads off of a table.
And it's a language that was largely invented in the 70s and the 80s. So, and so the Tidyverse, especially, I think its main, I don't call it innovation, but its main perk is that making it really, really easy for people to use their software. And so Hallie used this reference once from a Microsoft presentation where people talked about the pit of success.
Yes.
Where you want it to be so easy to use that people could like fall into it and do the right thing and not even know it. And that's especially important for modeling because there's a lot of situations, especially in like machine learning, where you could unwittingly do the wrong thing and not find out until later. And briefly, like when I was at my first company, now I was at a project, and I felt like, and I feel like I know a lot about that type of modeling. And I had a project that was like a quarter of the R&D budget, and we built all these models for molecular diagnostics, and they seemed to be working great. And then we got our first new patients, and we got them all wrong. And we figured out some methodological issues that other people around the time were figuring out too. So it wasn't like it was obvious. But there's a lot of things that we want to sort of make it easier for people to use and hard for them to do the wrong thing.
Right.
And so that's the whole idea behind Tidymodels, is we want to bring sort of like modern methodologies to people who might not be used to using them.
Absolutely.
So if you think about like how you think about like linear regression, right? There's a lot going on with linear regression in LM and things like that that you don't necessarily think about. And we know a lot more about how these things work in the field and the way that people use linear regression. And so when we give you interfaces of linear regression and they're different from what's, let's say, LM does, it's because we realized, well, yeah, maybe it's not a great idea to just repredict the data you use to build the model and things like that.
Hey, we got a really good question in here. I was just checking this out. One of the students has asked us, what are the differentiators between, would you say, Tidymodels and some of the other packages such as MLR or Caret? Obviously, Caret, I would say it's kind of a major advance. Componentry wise, you've got a lot more packages that are more specific. But what would you say kind of are some of the big differences out there that differentiate Tidymodels from some of these other kind of ecosystems?
Yeah, and generally speaking, they're all great. So, if you're more of like a base R kind of person, Caret might be a good choice. Caret makes a lot of decisions for you. So, there were a lot of things in Caret where I was like, well, we can give like a large range of options for people to do things. And like, what order can they do them in? And so Caret's the kind of thing that would prescribe the order. We would say, it makes sense to do them in this order, but then eventually there's things that you want to do that Caret can't. So Caret is in a way like kind of like a walled garden where if you want to do like the basic 80% and you're cool with that interface, like a function call that's got like 20 arguments to it or something like that, that's Caret, and that is like right up your alley.
Yeah, so, I remember just kind of using the same kind of format like PCA, then this, then that, and it did a good job with it.
So the only downside to Caret is I'm not really actively developing it anymore. So it's always going to be on CRAN, much to their chagrin probably, and I'm supporting it and things like that. Like all next week, I'm planning on just working in Caret, but it's not like gaining new features. So that's the downside of Caret. MLR and MLR3 are really good. They're very comprehensive. I mean, they have extensive number of graduate students that are writing packages, and they do a lot with MLR. I think the only thing that, it's not that I don't like it, but the only thing that doesn't come natural to me with MLR, it's very Pythonic. So if you really want to use R and you're a Python person, you might gravitate more towards how MLR3 works. So it's the way it does piping and things like that is very much like Python. So it's almost like a little mini Python infrastructure inside of R. And you might say like, well, scikit-learn is really comprehensive. Why would I use that instead of scikit-learn? And I think the answer is that MLR3 can do like, I would say 10 or 15 times more than what scikit-learn can do. Oh. So scikit-learn in Python is a very much like a very curated, like it's great as long as you order off the menu.
Right.
But in R, we have a much wider set of R packages for modeling. And I think the advantage of like scikit-learn versus anything in R is that R has just a wider availability of things that you can do.
Yeah. Well, let's switch gears here. Just briefly, maybe let's talk about some feature engineering. And while I'm going to let you talk about that, but I want to put this up as a book. So Max, for those of you who don't know this, he also dabbles a little bit, I'm saying that jokingly, into feature engineering. He actually wrote a pretty sweet book that is freely available. And David actually just put the link in there, but also it's available on Amazon.com. You guys should definitely check this out because I was reading it a lot, especially when I was developing this training today.
Yeah, so Kel Johnson is my co-author, and we wrote another book before that's pretty comprehensive. And
I think it's called Applied Predictive Modeling.
I don't want to I hate being on the show, but I'll do that. And so when we wrote that book, one of the things we wanted to do is...
He means this book right here, guys.
That's the one, yeah. So when you write a book, it's important, it's a lot of work. You have to say well, why do I want to do this? And it certainly might be like make a little money or get tenure or whatnot. But Kel and I, at the time, around, I think we started that in 2010. We decided that there wasn't really any good book out there on the practice of that type of modeling. So there's things like element of statistical learning that'll teach you okay, here's a theoretical, a fairly readable theoretical description of these models. And then there's software books that tell you the syntax, but there wasn't much of geez, what do I do when my predictors are super highly correlated? Or what do I do when, this situation or that situation? And so applied predictive modeling was more of us doing just as much of a brain dump of everything that we could think of. We just wanted a book where we could pick up and be yeah, that's covered in here.
Yeah.
And so once we were done with that, there was a couple of, that book's all about the models. I want
to put my 2 cents in before we switch into feature engineering. Applied Predictive Modeling and Intro to Statistical Learning. Those were the 2 books that when I was first learning, those were kind of my Bibles. So I was constantly referencing those and kind of, trying to apply them to my business data all the time. And just kind of see what works. Some stuff doesn't work, but for somebody who's just starting out, especially, kind of fresh from a business perspective, doesn't have a whole lot of technical training and machine learning. Those were gold. So just putting that out there.
Thanks. I'll try to speak a little louder. Somebody had a comment about not being able to hear well. That book was all about the models. So it's kind of like an encyclopedia at the time of the major modeling methods you might think about using. But the thing that we kind of knew at the time, but it's hard to write a book on it, at least at the time we thought so, is, your choice of model doesn't, in a lot of cases, doesn't I don't want to say it doesn't matter that much. But what we found is there's usually a panel of models, of different models that will give you about the same performance. So it's really easy to just try different models and squeeze about as much performance out of that as you can. But the thing that really mattered quite a bit was, well, what am I putting in the model and how am I doing that? And so the whole idea of feature engineering is that you want to expose your predictors to the model in a way that makes it as easy as possible for the model to use them, right? You don't want the model having a bend over backwards just because of the format in which you added the data. And so the example that we use quite a bit in the book is time. So, you think about having a date in your data, and hopefully this isn't encouraging anything you're about to teach, but you can encode that date as the number of days since a certain like reference point. You can encode it as month indicators and day of the week, or you can code it in all these different ways. And so, and it's really problem dependent. Like, let's say you just put in like the number of days from a reference point. Well, a lot of models might be able to eventually figure out how to use that data as best as possible. But if you take a little bit of time and look at your model and figure out, oh, well, here's what seems to be going on with that particular field, spending a lot of time figuring out how to encode data into a model solves a lot of problems. And, and I think the thinking right now for a lot of people would be, well, just let the machine figure it out. Like, just add more layers, right? It's like a neural network, and why worry about it? And so my feeling is that, the reason for that is that I feel like there's a lot of things that we can effectively automate in modeling, and this probably is not one of them. Because if you let the model figure it out, it's going to be hard to extract that knowledge. You're losing all this sort of subject-specific understanding of the problem, which is like really, really key. So I'd say like the choice of models is, for me, and this is the guy who wrote like a modeling book, is less important than how you configure and encode the data that goes into the model. That's really what makes all the difference.
Yeah, I'm 100% in agreement with you. I mean, based on, what I've seen, I mean, so most of the stuff that I develop is based on my experiences, right? Either like from an industry or from actually working with business sciences, real customer data. And like, I'll be honest, the features are way more important. Like if you don't have the right features, stuff that that's really important for customer data specifically. It's exactly what you were just talking about with the date features.
Date
like
location, especially.
Yeah. I mean, if you're doing a time series forecasting model, certainly you need to have like all the month, year, those types of, those type of features in there. But like for customer data, especially, you got to have the tenure, you got to have when they last purchased, you got to have certain things like that. And we're actually going to do some of that today. Those features end up oftentimes the date related tenure features end up being super critical to your model performance, whether or not, because you're usually trying to predict something like whether or not that customer is going to, purchase in the next X amount of days, or, how likely are they to be a repeat customer, that type of thing.
So yeah, that's what that book is about. It's basically, we have a lot of examples that hopefully will maybe not be as applicable to whatever like weird data set you might have on a daily basis, but hopefully it'll give you a lot of options and the software behind it. Like, oh, here's how I do that, to figure out like, what are things I could try? Because, one cool thing about predictive modeling machine learning I like quite a bit about it is it's really easy to be creative, right? So to think of like, oh, well, location in this data set's important, and it's like sale prices of houses. What if I encode this house's different distance from a school that people really like? Right. And so, it encourages you to really try different things. And the idea of like empirical validation, like resampling, things like that is, it gives you a very, very fast feedback loop to say, oh yeah, that was a bad idea, or that didn't matter, or, oh yeah, that cracked the case, kind of thing.
Yeah.
So it's enabling.
Yeah, and for businesses too, especially where it's normally like people consulting with, subject matter experts. They may not be data scientists, but they may know marketing really well. That kind of back and forth and communication can really bring about new ideas for features, such as something that the data scientist alone, may have no clue about, and it can uncover also a gold mine, which is new data. Different things that you can look at, like combining your own internal data with some external sources and that sort of thing. So, all right. Well, very good. Let's, so Max, is there anything else you want to say? I also wanted to let you guys know, I already flashed this one. We're going about 30 minutes in. So if you have another minute or so that you want to talk about anything.
There's a question or two I saw that I could address.
Yeah. Do it. Go for it.
So one was about like back transformations of data. So like you write a recipe, you transform your data, and put it into a model. And the question is, it was one we get quite a bit. reverse transforming things. We've gotten that question asked a lot, and I think we'll eventually have a method for doing that when it's possible, because it's not always possible to like unbake a cake. But I'll put something in here, not to like single somebody out, but here in the links is like an example of like this conversation I've had the other day where maybe I just need to understand what people really want more, because like if you have the original data and you run it through a recipe and you put it in a model, like back transforming it, let's say we're just talking about the predictors, like you have the original data if you're making predictions and running it through the model. So so if I'm not hitting the use case that people want for this type of question, it'll be great to either like respond to that link and give more detail about what you're interested in, because maybe I'm just not getting what people want. Because I've thought about this quite a bit, because a lot of people have asked, but I don't know that it's possible for a lot of things.
Yeah, I think
like the hashing function that Matt's going to talk about in a little bit is a great example. Once you have that, there's no real way to back transform that. But even if you could for something simple like centering and scaling, well, you wouldn't have those normalized values if you didn't have the original values. So like maybe I'm not understanding, but like you already have them back transformed.
Yeah, and just to add to what you're saying, I mean, you know, that's the reason that we hire data scientists, is because they need to be able to kind of back transform, you know, undo the cake as much as they can. You know, like the recipes is great because it keeps track of, you know, your log and your centering and your scaling, and you'll have the means and stuff in there that you can do kind of simple reverse transform or inverting. But like what Max's point is that, you know, you don't always know exactly, you know, what needs to be untransformed and how to do it. And I think a lot of times, I think the data scientists, you know, we need to think outside of the box too, as you know, maybe it's the target variable, but if you're investigating something, you know, you can kind of combine the original data with the transformed data and maybe do some investigative like EDA to explore like some visualizations that mean something on untransformed data. So not to get into like too, you know, much of a kind of heated debate on inverting transformations, but I think, you know, at the end of the day, it's kind of impossible to be able to automate the inverse transforms in a lot of cases. Okay, any other questions that we wanted to hit now, or are we ready to jump into some actual tackling some code?
No, would it be okay if I answer a few in the chat while you talk?
Yeah, absolutely. Please do.
Okay.
All right, guys. Well, we're going to get started here with a business problem. And this is a nasty, nasty problem. It's a database, a pretty big database. We're going to be focusing on some customer analytics here. And I'm going to be showing off some of the cool feature engineering that we're going to be doing. So let's talk about Led Zeppelin. I want to talk about some music right now. And it's because we're working for a company that's like iTunes, that has customers who purchase music from an online merchant. So we want to learn about our customers, like some questions we might ask, or our company may be asking, are what products are my customers purchasing? Who is most likely or least likely to purchase in the next 90 days? And if you're getting these types of questions from your company, you're not alone. I ask these a lot of business science data. You know, who's going to be purchasing in the next 90 days? What are they going to be interested in? Those types of questions. Well, what we're going to be doing today is be doing a master class in feature engineering. And I'm using a data set. I actually got the question in my Slack channel for my 101 course this week. So those of you who are not in my 101 course, I give two data sets. And the original intention of that course was to be, it's the beginner level course. And, you know, I give a data set that's based on some bikes. And then I also give this Chinook data set, but I never actually use the Chinook data set in the course. Why didn't I use it? Because when I actually got down to developing a beginner course, I realized, holy crap, there are 11 tables in here. There's dates, there's zip codes, there's countries, there's addresses, you know, and for a beginner course, I just felt like it was a little bit too much. But we're in Learning Labs Pro now. So it's time to up the ante a little bit. And now is the time to wrestle the Chinook database. So this is a freely available database. A lot of people use it when they're developing databases to test their databases out, their linkages, and so on, and when they build, GUIs on top of it. We're going to use it for machine learning purposes and customer analytics. So what are we going to be doing today? Well, I'm going to be writing 350 lines of code, and it's going to be in depth. It's going to be raw. You're going to get to see lots of left joins. You're going to get to see lots of feature engineering. We're going to be talking about hashing. We're going to be talking dates. We're going to be talking UMAP. If you've never heard of any of those, well, that's why we have Max on here. He's going to explain what those are to me while I'm coding. So we're going to wrangle it, we're going to feature engineer it, and we're going to model it with XGBoost. The results are going to go into an app. That app is being given to all of my LL Pro members as a bonus. It's called the Customer Explorer application. It's Tableau-esque, and it allows us to drill into customers. So let's take a real quick look at this application before we dive into the actual code. So I've got this app here. It's called the Shiny Customer Explorer. So you can imagine if I just pull it up, and we've got all of our customers in here in our database. And what this XY axis, what the scatter plot here is, this is an actual customer segmentation tool. So customers that are closer to each other are purchasing similar content. So if I click this customer right here, this person is purchasing a lot of music. The highest frequency is Deep Purple from the rock category. And if I click on this person here, and if I deselect this one and click on this person here, we can see they're also purchasing a lot of Deep Purple. How did those people get clustered together in the segmentation tool? Well, that's with the step UMAP. We're going to talk about that in a little bit. So this is kind of how the tool works. This is really great for a business because it allows them to see and access their data in an interactive way where they can drill into it. So you can imagine giving this to a non-technical person, maybe somebody who's in charge of marketing, and they want to know, when to send out emails to whom, and they can use this tool. So say these two people right here, this person right here has a purchase probability of 0.91 in the next 90 days. Probably don't need to send them an email to get them kickstarted. But this one here, purchase probability of 18%. Maybe want to jump in on them. So we click them and we can see this is what they're interested in. We can tell, we can maybe customize an email that is focusing on Deep Purple and some of these other kind of categories here. And then I can switch over quickly to my customer data dashboard and I can copy it. So I just got the, whoops, that's all of the data. I just want to have this person right here. Click that, there we go. So this is the person, 18% probability. Whoops, why did that go back? That's not supposed to do that. There we go. And then I can copy their entire purchase history of 38 rows here. So this is all customer ID 38. I can see which tracks they've purchased. I can copy that. I can download it as Excel. And then I've got my Excel show that in my Finder, open it up, and I'm ready to start kind of analyzing what information that they've been purchasing. So it takes a second to open up. I'm actually opening up now an Excel file with this exact data for this particular customer, shows what they bought. All right, so that's the idea here. We want to be able to build this application today. How are we going to do it? We're going to use R. So for my LO Pro members, this is the project that we're working on today. It is pretty heavy duty. It's a feature engineering is the main file we're going to be working out of. So this is what the files look like. O1 and O2 are what we're primarily going to be working out of today. O1 is the feature engineering clinic, and O2 is the bonus Shiny Customer Explorer app that I just showed you. There's also a data folder. So the Chinook database is the SQLite database we're going to connect up to. And then these RDS files, we're actually progressively going to make these as we go down through the lesson. So, and then those get fed into the app. Okay. So we got some basic questions for our business. They said which customers are similar and what relates to customers repurchasing within 90 days. So they want to understand a little bit of insights about their customer base, and they want to use it for their marketing team so they can make some actionable decisions, target some specific customers. The learning path today. So we're going to find some relationships between customers using step UMAP. That comes from the embed package that Max and company have been building. It's part of the Tidymodels ecosystem. We're going to combine many tables using in a customer database. We're going to reduce dimensionality. For example, the number of zip codes. We're going to use a technique called hashing, and that comes from the embed library as well, the step feature hash. We're going to model 90-day repurchases using XGBoost. And then what we're going to do is identify important features for business intelligence. Okay, so let's get started. Libraries, we got to load a lot of them. DBI and RSQLite, that's for connecting up to the Chinook database, which is a SQLite database. We're going to use Plotly, Skimmer, and ggAlley for EDA. These are visualization and exploration tools. We're going to use some modeling tools. So Tidymodels, Embed, Text Recipes, and VIP. And then we've got some core packages, Lubridate and Tidyverse, which helps us do basically data wrangling. Okay, so now we're in part A. So the way I have this structured is A is the first part. We've got part B, which is going to be feature engineering, and then part C, which is modeling. We're going to go through it all. So database connections. I'm connecting up to a database right now using the DB connect, and this is connecting up to my SQLite that's right in here. It's connecting up to this. I'm going to list the tables that are in it using this DB list tables with the connection object passed. And I can see that there's all 11 tables in here. This is the 9th one, 10th one, and 11th one. So each of these are different tables in this database. So I can access them using this Tibble function. So Tibble con invoice, I can see pulls in the, here, let me stop this so it saves a little bit of memory. Here we go. So I can see it pulled in the invoice table here. It actually didn't pull it into R though. I have to run this other function collect. So it's just connected to that database. Once I run collect, now I can see it says Tibble of 412 by 9. So we went from a table that's kind of a view of the database to actually pulling it into our memory when I run this collect function on it. Quick tip, if you've ever run across a database that has more than one table, how do you view all of the tables in it? Well, here's how I do it. I take my DB list tables con and I pipe it into map Tibble con with a dot. And what this does is it's really handy. I just now pulled in a view of all 11 of the tables. So I've got album here and I can see this is what that table looks like. I've got artist here. This is what that table looks like. Customer, this is the customer's database table. So that one's gonna be pretty important. Employees, probably not as important. Don't really need to know who the sales reps are. The genre, that's gonna be important because this is related to products, right? So which genre does the album that they're purchasing come from? Invoices, this is gonna be very important. We need to know what the dates were that the customers purchased. And we need to know the total price that they paid for that particular invoice line. This is going to be really important. This actually breaks down each invoice to show us specifically which products, which track IDs were on each of the invoices. So that's going to be super important. Media type, maybe important, who knows? Playlist type, don't know if that's going to be important. And then the tracks, this is the products data. So we need to have the tracks database. Okay, so just to recap here, use this map and you'll be able to get a view of all the tables in your data set or any tables that you have here in this DB list. And if you don't want some of these, you can kind of filter them down and then just run it through this map. All right. Invoices, let's start there. So what I'm doing is I'm pulling in the invoices. I'm going to check out this invoices table. I pulled it now into R because I run collect on it. And guess what? We now have a database that looks like this, or a table that looks like this. I see pretty quickly here, this invoice date, it's a character. And that's just a function of how SQLite stores data dates. So I need to convert that to as date. Otherwise, I'm not going to be able to work with it too well. So now I'm doing a glimpse of that same data. I can see there's date and the rest of the data seems to be okay. And then I'm going to pipe that into write RDS because I'm going to use that in my app later. Okay, moving on. Customers. We're going to pull in the customers data. Check that out now. All right, so this is important because we want to model our customers. This is like the top level of our data though. So we need to drill into what each of these customers are purchasing. But this is going to be the last thing that we work with. We're first going to move on to invoice lines. So we're going to start at the bottom level. So this is specifically what people are purchasing. Basically, think of it like products. We want to know, we want to first pull in our invoice lines, which looks like this. It's not very useful in this form. We need to add things to it. So we've got to add the products, which are the tracks. So we're going to do a left join on tracks, and this adds some of the track names in here. We got to pull in the genres. The genres like rock or Latin or, whatever other genres are in music. Apparently, I only listen to rock and Latin. So those are the only two that are coming to me. Albums. We need to know what albums are purchasing. We need to know what artists are on those albums that produced. So we're progressively adding in more and more left joins. And then what we also want to do is pull in the customer ID, because we have to have a way to relate these invoice lines to a specific customer. Otherwise, we won't be able to mine for trends by customer. So that's what I'm doing here with the invoices. The key is there. We have to left join the invoice lines with the customer ID that's located in the invoices. Okay, so once we do that, we run all of this, and this is what our data looks like now. So we have at a granular level, we have every line on every invoice. So this invoice is invoice ID 1. It has 2 lines. That's 1 and 2. What those are specific tracks. So it has a track name, Balls to the Wall and Restless and Wild. And we can see that those both came from rock genre. And we can see that the artist name is Accept and Accept. So that's how it goes. So what we've done is just pulled in all the data, and we're basically now able to, at a very granular level, link customers to the products that they're purchasing. So let's get into some feature engineering. Or actually, before we do that, what I'm doing, so I just glimpsed it. I wrote the data to this data folder because I'm going to use that later on in the apps. And then now what I'm going to do is I'm going to check the data set. So I'm going to run the skim function on it. If you've never used skim before, it's an 80/20 tool. I love this function. It comes from the skimmer package. It shows me where I'm missing data. So this composer has 73% missing data. That's probably not going to be too useful of a column for me. But what I can see here is I've got my character data type. These are the character columns. I can inspect for data issues. And this data set actually looks pretty clean, other than the composer column. And then the numeric type, I can see that this is all pretty clean here. It's got a completion rate of 100% for all of these. So that's actually looking pretty good so far. Okay. Now, last thing before I move on to feature engineering, I want to disconnect from my connection. It's always good practice when you're connecting to a database to disconnect from it when you're done. We've got all of the data in here that we need. I've got all sorts of data sets in here. Okay, so next what we're going to do is we're going to focus on some feature engineering, but what we're specifically looking at are product relationships first. And then we'll see kind of a pattern. We'll go from product relationships, which is at the lowest level, meaning what specific tracks and what specific genres are people purchasing. Then we'll move up a level and look at purchases. So this is like their invoices. How many, what kind of information can we glean from that? And that's where the date features will come in, and also price features. And then we'll move up the highest level, which is the customer features. And that's where we're going to pull in kind of aggregated data that we glean from these lower level insights. Okay, so it all makes sense here in a little bit. Product relationships, customers and artists. So I'm going to focus on invoice lines here. This is again the lowest level. So our invoice lines is the item that we just put together. That's this kind of data here. And what I'm just quickly did was I looked at artist name, because I think that that's going to be important for a feature. So we want to know who's buying what artists, and we can kind of use that to group them together and do our clustering or customer segmentation analysis. So how do we understand who's similar? That's the question here. We want to know who's buying what, and one way we can do that is just specifically look at which artists that they're purchasing from. So we can, in order to do that, we can take our invoices line tibble. We can just select our customer ID and what artists. So I can see there's 2,240 rows by 2. And what I can do is count the frequency. Once I have it in a frequency, what we need to do is we need to be able to compare these customers. So right now I can't compare them. One way to do that is we can make dummy columns, and we can use the pivot wider function in order to be able to do that. So what this pivot wider does is it basically turns that, so it was 923 by 3. It kind of pivots that data. So now I have each of the artists listed along the columns, and then the customer IDs on the rows. And I have their frequency, how many tracks that they've purchased in here. And this is the format. I call it like it's a user items table or a customer products table. But basically this is the format that you want to have it in order to be able to start kind of addressing the similarity. So we're going to save this as customer artist tibble. Let me just make sure I save this properly. Okay. All right. So it's a wide tibble now, 59 rows, because I only have 59 customers, and I have 166 columns of each of the artists that they're purchasing. So this is getting pretty wide though. And one of the cool things that we can do is we can use a dimensionality reduction technique called UMAP. Now, I actually teach this in my 101 course, but I built that course before before the recipes or the embed library, the embed package was developed. And embed has this really cool recipe where we can just pipe it into step UMAP, and it does the UMAP for us. So it basically condenses all of these columns here. It's 165 columns. And what I'm going to do is I'm going to condense all of that information, or as much information as it can get, into 20 columns. And what that does is it helps my algorithms out, because they don't have to, the wider your data set, the longer your algorithms are going to run. And it also gives us a way to visualize. So Max, is there any, do you want to make any mentions on the UMAP? I know I'm not really getting into any of the theory or anything, but is there anything that you want to talk about?
Yeah, I could briefly say something. And if you haven't figured this out already, if you can hear it, that is my dog snoring in the background.
Nice.
So UMAP is basically, if you've heard of tsne, it's a variation of that. The nice thing about UMAP that's better than tsne is tsne you can't project on new data. So with tsne you can only like do these data reduction operations with your training set. You couldn't take that and say, well, where would the new data sit in that map? And UMAP does that. So you can think of both those methods as a very, very, very non-linear version of like principal component analysis. So in a way, it's using these things called manifolds to sort of, in a way, project the data into like a non-linear format, so it can potentially pick up on a lot of patterns in your data that PCA would not be able to.
So, yeah, any quick pros and cons between PCA and UMAP?
One is that UMAP can be supervised. So, so UMAP, you can give it an outcome and let it try to find a mapping that it likes that tries to separate the data or make it more predictive. Now you could do that with PCA just by using partial least squares too. So it's a little bit of an advantage. UMAP, when I've seen it, and it's hard to do many dimensions in UMAP and tsne, which you know with PCA is very fast and easy to do. So in terms of like computational time, PCA is much easier because it's a simpler analytically defined problem. I use both quite a bit because you might think like, well, UMAP must be always better because it can do things that PCA can't. But the simplicity of PCA sometimes is helpful. So for example, if I'm doing like a classification problem and I have like 100 predictors, I might use PCA to make those predictors down to 2 components and then color them by the outcome class.
Right.
And the nice thing about that is if I see some separation between those clouds of data in 2 dimensions, then I can probably get a good feeling that, oh, well, this problem isn't all that hard because a linear method like PCA can separate them. And so it gives me information about like, what approach should I take to modeling, because the problem, if PCA can solve it, the problem can't be that complicated. But if it doesn't, then it might be that there's no information in your predictors, or it might be that you need something like supervised UMAP to see if there's a difference.
Right.
So you can use them each to like maybe troubleshoot the other to figure out what path you should take on modeling.
Yeah, that's a good point of using multiple algorithms to kind of glean insights. I know with PCA, one of the things I love about it is you get the loadings as well, and you can kind of put those as vectors. You put that in front of an executive, and you kind of, and then you show them, you know, hey, like, I know I did this with the cars data set recently as part of the RTIPS videos that I put together. And I did it on like the, I think it's the MPG data set. And it actually showed like the loadings of like, hey, these cars all have more horsepower. And it was like the, Mustang and the Corvette and all those down there. And then at the opposite direction, it was, all of the like kind of like Honda Civics and those sorts of things. So it was really easy to understand and it made intuitive sense. UMAP, you can't, at least I don't know. I don't believe you can do that. Yeah. UMAP's kind of like the high performance end. I feel like it does probably contains more information, but you're never going to be able to
you can't really back transform that or figure it out. It involves a lot of like nearest neighbor calculations too. So it's not like an analytical, it's
right.
Box,
Right. All right. So what I just did, thanks for that, Max. What I just did is I actually ran these few sets of lines. And so before UMAP, remember we had oh shoot, I knew it was going to do that. Damn it. Got the freezing R. Just bear with me a second. I can get back to it. I saved the data. That's another reason I was saving my data for this lesson. Because I sometimes R shuts down on me. So let me just quickly get back to where I was. Let me run through here. And what I want to do is I want to pull in my customer artist UMAP. So back where I was, sorry about that. So the 166 rows, when I ran UMAP on it and I saved it as this customer artist UMAP. So I just pulled that back in. You can see it gives you these columns called, UMAP 01 all the way up through 20. And that's because I put number of components in here as 20. You can put as many components as you want or as few. And then what's nice is that my algorithms, when I run it, it won't take nearly as long to run on 20 columns as it will 166. And it'll still have about the same amount of information. Plus, as an added bonus, we can now answer which customers are buying from similar artists. So we can do that using ggplot. So if I just plot, think of these like Max was saying, principal components. So UMAP 1 and 2, I'm going to visualize those two in an XY. So we can make a 2D scatter plot. I'm going to use ggplotly here. And that gives us this plot that looks like this. So if you remember in the in the customer exploration, that's this plot right here that I have basically that I've built off of this UMAP. And it's just taking those first two components. We can even make a 3D plot too, which is nice using Plotly. And sometimes this is beneficial if you really want to kind of like understand, which clusters are, if your data is getting more and more complex. And I actually have the fourth component as the color here. So you can really see which ones are closely related. So I know that 55 and 35 are really close. and so on. So, and the other thing is like 35, 55, and 16. I think that was these here. Yeah, 35, 55, and 16. That's these three. So we can kind of then investigate them a little more. And I can see here, oh, those customers, all right. So they're buying a lot of Iron Maiden. They all seem to like Iron Maiden. Makes sense. They like Metallica. We got Metallica there. We're seeing some U2 as well. U2 comes up, and those are pretty frequent purchases. So that's why UMAP is putting them together. So that's how you can kind of get to the explanation there. So now this is the visualization, or we can do the 2D version of it. And this is the visualization we can use then in our application. Okay, next, aggregated features. So if you take a look, so we just did the, what are they purchasing, the artists. We can take a look at some other ideas. Maybe certain people all like kind of shorter songs or longer songs. So we can take a look at length of song and make those types of features here. So this is how we would do that. This is kind of a neat trick that I just found out about. So what I'm doing is I'm taking my invoice lines and my customer ID and then the milliseconds. So I have the length of the song here for all the songs that they're purchasing. So you put that into a table that looks like this, 2,240 again, and then I can use a summarize, and I want to use the quantile function because I want to have, I want to know what the minimum song that customer is listening to, the maximum length of song, the 25th percentile, the 75th quantile, and then the median, which is the 50th. So I can use in frame and quantile to do that. It's pretty cool. Now I have that by customer. Then I can ungroup. I can get rid of this percentage here in that column. And then I can do another pivot wider. And now I have customer ID by song length, like that. So it's that easy. This is all just basic data wrangling stuff I teach in the 101 course. Cool. And then you can get some insights. We can arrange it by length of song, and we can see that 51 and 40 are all listening to longer songs, and so on. Okay, cool. So we've just mined for kind of specific products that people are purchasing. Next, what we can do is move on to purchasing relationships. So these are like date features and price features that come from the invoices table. So now we're going to be focusing on the invoices. So the first thing I'm going to do is we're going to be working with date features. So what I'm going to do is I'm going to get the max date out of the invoices table, and that's going to be my baseline. So every date, when we start to do some analyses, basically I'm going to be looking at days from that max date in the database. So 2013, 12, 22. What we're going to be doing here is first taking our invoices table, which looks like this. It's got all of the invoices in here, and it has, and think of invoices as like the aggregate of your invoice lines. So your invoices will have the total price, whereas your invoice line has the price of each product that they bought. But what you don't get out of the invoices table is you don't know specifically what products they purchase. So we don't see any of that in here. But we do have the date, the timestamp. So that is a feature that we can utilize and compare that to the customer. So we can come up with things like, okay, what is their most recent purchase? Or we can come up with features like tenure, which is like, okay, how long have they been, when did they make their first purchase? How long have they been with us? You can also come up with features related to the pricing column as well. So the number of invoices that they've had, the sum, the total aggregated value of their invoices, the average value of their invoices, and so on. So when I run this section of code, that's what we get. And you can see here, we got the customer invoices. We now have by customer ID. So there's only 59 rows because we have our 59 customers, and we have some information now about their purchasing habits. So when was their most frequent, how long have they been with us, and then related to the pricing and the number of invoices. Okay, cool. Another thing at this stage, GG pairs, and this is something that I use in my 201 course. I really like this function. It comes from the GG Alley package. And this is just a useful way to kind of see, the distribution, and you can usually find some interesting things out about the distribution. For example, like I can see here that there's kind of a bimodal thing going on with the most recent purchases. And I can see here that it tends to be more recent. So less negative is more recent. And I can see there's more purchasing going on more recent than in this cross-section of data. I can also see weird stuff, and this may be because this was a manufactured data set, that the invoice most recent and the invoice tenure are very closely related, or it might be just kind of happenstance that it looks like this. But I think it's probably because somebody created this data set. And then you can see kind of like the buying pattern, the invoices, the sum of the invoices tends to increase as we get closer to now. And we can just get a lot of information out of this. So pretty cool. All right, next thing. Now we're done with the purchasing relationships. We're going to move on to the customer features. And this is where the rubber hits the road, because now we're getting to that final data set that we're going to be able to mine for and use machine learning on to mine for customer purchasing patterns. Remember that question. We want to know, when did customers, what's the probability of them purchasing within the next 90 days? And we want our marketing team to be able to kind of hone in on those people. So we're going to try and make a classifier out of it. So customers tibble looks something like this. Customers tibbles tend to be pretty nasty because you're dealing with a lot of information that's text-based, like addresses. It may be information like an email address where you don't have it for everybody. Might be like a fax, for example. Here we don't have the fax address. We don't have phone number for a good, like the completion rates definitely go down. The state here, that's only present in 50%. Company is only present in 16%. So a lot of these features you aren't going to be able to use, but there will be some good features that we can use, like postal codes or zip codes, the country and the cities and those sorts of things. So we'll be able to mine for geographic relationships between customers. So what I'm doing here is I'm taking my customers tibble and I'm just selecting down the columns that I want. So I'm going to be utilizing the postal code, their support rep, the country code, and the city. And I'm going to be trying to create some information out of those. I'm also going to left join here with my customer invoice table and the customer song length and the customer artist that we created previously. And what this does is it basically merges in all of those features that we had been doing all of that hard work to make. So when I do that, it takes a second. The data set now has the invoice features, the invoice count. It's got the UMAP features in here. It's got the song length features. And now I'm starting to bring everything back together. And then the last thing I do is I like to keep things organized. So anything with UMAP, I'm going to put artist underscore, because that just reminds me that these UMAP features are all related to the artist. So I'm going to hit Control and Enter here and take a look at that. I'll glimpse it. And these are all the features I now have to do my machine learning on. I still need to do some work though on some of these, and that's where we're going to get into hashing. Okay. So last thing I'm going to do, I'm just going to do a quick skim, make sure that my data looks good. Let's see, we do have some missing data here, but I can, and I'll talk a little bit about that once we get on to modeling. Okay. So modeling setup, what I'm going to do here, I still need to create a new feature because the question that I asked was who's going to be most likely to purchase within the last 90 days or within the next 90 days. So what we can do is we can create a feature called target, and it's just going to be a simple feature. If else their invoice most recent purchase is within the last 90 days. Now it's -90 here or greater than that. So remember, less negative is more recent. And basically what that's going to look at is right around here is about -90 for our most recent purchase. It's going to look at, going to encode these people as 1 and these people over here as 0s. Okay. And then I'm going to make that a factor. And then I'm going to drop out the invoice most recent purchase because we don't want that as a predictor. It'll be information leakage. And then I'm going to relocate the target before the customer or after the customer ID. So I'm going to call this my full data. This is normally, it's just a term that I use. I call things full data. And if you take my time series course, you'll know what I'm talking about when I say full data, versus like data prepared and future data and that sort of thing. Those are common labels that I attach to data at certain processes. Okay, so this is what our data looks like. I still, again, need to take care of a few of these features. Before I develop a predictive model, though, I need to split these up. So I'm going to do an 80% split, and it's going to be a random split. So I'm going to set the seed, and I'm going to, and I have now a splits object. So what I'm going to do then next is I'm going to actually compare dummy encoding, because we can do dummy encoding for some of these features as well. So I'm going to create a recipe here. And I'm actually, I did KNN impute, but one thing to think about is that with XGBoost, because that's the algorithm that I'm going to run on this data set to produce my model, XGBoost can actually handle missing data. So we don't really need to do the imputation step here, but I'll run it just for people who want to see. We can do a KNN impute. There's also bag impute or linear impute from the recipes package. So I'm just going to do a KNN impute, and then we can see our, let's see, email doesn't exist. Why is it giving me that? Column email, step remove email. Maybe if I remove this here, run this. Okay. All right, so you can see we now have 139 columns and only 48 rows. So we're starting to get pretty wide. And one of the dangers, especially if you're doing a lot of different algorithms, is that as the more columns you get, you definitely need to use, like if you're using linear or logistic regression, you need to have some sort of algorithm that's going to be able to regularize, because you're going to get a bunch of columns that your linear regression or your logistic regressions are going to overfit, and it's going to cause really wonky predictions. So a trick is what we can do is do this thing called hashing. So instead of having like for every single country and every single city in here, what we can instead do is this trick called hashing. And it's kind of a similar idea as the UMAP, where we're taking a bunch of wide features and doing this thing called a hashing trick, which I don't even know what that means, but we'll ask Max here in a minute. But all I know is it compresses all of that wide data, 100 and some columns, into a lot fewer. And the number of hashes I'm going to say is 15. So it's going to compress country, city, and postal code into 15 columns each. So I'm going to run this, and while I do, I'm going to ask Max, what the heck is feature hashing?
So when we think about normally making dummy variables, we have like this, we almost have this dictionary where we know all the levels that are going to be in the data and like traditional indicators. And then we could say like, oh, well, we have like, I'm thinking of like the Ames data, like neighborhood is equal to North Ames, then this column gets a 1 and otherwise it gets a 0 and so on.
Right.
What feature hashing does is it uses the actual value of the level, and it computes, it's basically using like cryptographic methods to come up with like a hash value, which looks like it's a random like jumble of strings, but it's actually, you can deterministically compute it to basically assign that value of that level to one of however many columns you want to try to use.
Right.
So so it's a different way of creating dummy variables. You can create as many as you want, and you can't easily, if at all, like map back to like, oh, if I had a dummy variable of this, what was the original value? You can't get back to the original. So that's my best way of saying it is it doesn't know about like all the data in your data set. It only knows like in my example of like neighborhood is North Ames, it would take literally the string of North Ames and use that to assign it to, let's say if you want to have like 100 hash values, we'd figure out which one of those hundreds it should fall into.
Right. Yeah, and I know too, they use it a lot in text, because I know even the text recipes, they have a recipe that I wish I knew about when I did the training last week, but it's the step text hash as well, where, because you get these really wide data sets, and like I ran a linear regression on it, and we got, as we had 200 plus features, I mean, the predictive performance on the out of sample went up, 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 and then all of a sudden just went off a cliff. I mean, it did horrible. So the feature hashing, whatever that trick is, I mean, it can definitely help. All right, so let's take a look between the dummying. I just want to compare. So you got your dummy, which looks something like this. I'm doing a glimpse on my dummy. Or I just juiced it and extracted out the data from my training post doing the dummying process. And I can see that it's 139 columns. So it's really long, and it's got that's because it's got literally a column for every single city and postal code. Well, the hashing, so remember it's 139. Hashing doesn't fully, it's a lot dependent on this number here, 15. So you can see there's 15 different postal code hashes now. There are 15 different city hashes and so on. So, and what it's doing though is basically kind of like that dumbing process where we now have zeros and ones in there, but it's created a lot fewer columns, which again is going to speed up my algorithms. Now, it's not like we have an insane data set here of 48 by 77, but you can imagine if you have a customer database that's 48,000 rows by, hundreds of different columns, because you've got a lot more postal codes, it can be quite an improvement. It might even actually give you better predictive performance, especially if you're using simpler algorithms that don't have regularization in them. Okay, let's do some modeling here. First, I'm going to do the dummy. So I'm just creating a workflow here, adding a XGBoost model, applying the dummy recipe and training it. And it's created a training data set. Now I'm going to run it on the test with predictions type prob, because that's going to give us our probability. And I'm passing it through yardstick ROC. Now, a couple interesting things. You'll see that the new data actually has new factors in it. Now, XGBoost, it looks like it handled it okay, but you'll also see when I do it in a minute that with hashing, I'm not going to get this type of error. So that's a good thing. And you can see that the predictive performance is about 0.71. So it's definitely better than 0.5 is kind of the baseline. It's going to be better than random guessing. Obviously, you want it closer to higher numbers are better. So you want it closer to 1. 1 is the maximum. That would be like perfect predictions on the out of sample. And we're 0.71, so we're not horrible. The hashing now. So this is basically the same workflow. I'm just swapping out this recipe spec hash. And what I'm doing here is I'm just running the same prediction and doing the ROC AUC. You can see here it did slightly worse. It just kind of depends on how many features you have in here and so on. So maybe if I was trying to improve this, maybe I want to try and increase those numbers up a little bit on the more important features, but we're just going to run with it for now. The next thing I'm going to do is I'm going to check out the variable feature importance. So this is going to give me which are the most important features, and I can see tenure is a pretty important feature. We're going to want to check that one out to see why are people in the 90-day more likelihood or less likely, and how does tenure relate to that. So, and we can see the song length, the max song length, those type of people seems to be pretty important. And also some of the UMAP features, like what are they purchasing, seems to be pretty important. Okay, so the full data set, the first thing I'm looking at is this tenure, and I can see that it looks like a difference. So 1 is more likely to purchase in the 90 days and 0 is less likely. And what we can see here is that if their tenure is lower, it seems like they're a little bit more likely, because that's where the difference is. Conversely, if they're longer in tenure, they're less likely to repurchase. So this is a good marketing piece of information, good marketing insight, because you can say, hey, like if they're in this window, you don't want to let them get to this window because they're much less likely to purchase. So you want to start, kind of reeling them in before they get that far out. And that can be a good sales strategy. The next thing we want to look at is the song length, see if there's some differences. So there's some slight differences. People who listen to it looks like a little bit longer songs are more likely to repurchase. So who knows why that is? We'd have to do a little bit more analysis. And then UMAP 16, again, we don't actually know what UMAP 16 really even means. We'd have to investigate these features much more thoroughly to understand which artists people are buying more of and more likely to make repurchases with. Okay, so we've got our predictive model. Now we're ready to save this data set, and then what that data set goes into is this Customer Explorer. I'm just gonna zoom to the top of this real quick for my LL Pro members. You guys are gonna get this app. I'm gonna click the run button. Couple of points. So Shiny 1.6 was just released, and actually at the RStudio conference, they talked a lot about this library called BSlib. If you want to be able to use this, that's how I'm getting these custom themes in here. That's how I get like this gray kind of the color scheme or CSS themes. Also, this font in Google is Oswald. You can pick any Google font you want, and it pulls it right in. It's really cool. If you want to be able to use that, you need to download the latest version of our Markdown, which is not the one on CRAN, but there's a newer version. So I have it installed from GitHub. Here's how you do it. You just run this line of code here, remotes, install GitHub, RStudio, or Markdown. So make sure you have this version. This is the version I'm running. Also crosstalk, because what happens is when I click on these, it drills in. The way I get that kind of like Tableau effect is using this library called Crosstalk, and you'll want to have the latest version of that as well. And then you'll be able to run this, and you've got now your Shiny Customer Explorer that you can start to drill in and look in segments and see what they're purchasing. And you can basically swap out this data set with your own customers' data, and pretty quickly you've got an application that your company can use. So all you got to do to get this, join LL Pro. All right, let's go through some quick conclusions. So I just want to recap what we've done here. These are the conclusions we kind of walked through. We found some relationships between customers. We did that using the step UMAP. We combined many tables within a customer database, and you saw kind of how that hierarchy and that really nasty data set, the Chinook data set was. We had to reduce dimensionality, and the reason we did that was in order to prevent our machine learning algorithms from taking forever to run. And then we modeled the 90-day repurchases using XGBoost, and we identified some important features for business intelligence. And we even created this application, which kind of packages up our analysis in a way that's kind of more friendly for the marketing department. If you're interested in learning more, we've got the R-Track courses. I will talk more about those at length, but that's really designed if you really want to learn in depth how to use RStudio, Tidymodels, and the ecosystem, and also build your own Shiny web apps. It's great to get the code here, but like at some point you need to learn how to develop Shiny yourself if you want to be successful with your company and building Shiny apps for them. So the R-Track kind of gives you the whole pathway there. LL Pro, this is great for intermediate users that want this code, that want to be able to reproduce all of the results and basically like apply it to your own problems. Okay, cool. So that's the training. Max, I am going to go into a little bit of kind of a promotional piece here. You're more than welcome to stick around. This is basically for the people who want to learn more about the courses and stuff.
Okay, I'm gonna head out. Thanks for having me.
Thanks. Yeah, thanks so much for coming, and I really appreciate it. You're your insights and just hearing your story is amazing.
Take care, Max.
See you.
We'll see you. All right, guys. So I want to talk about learning more real briefly. Like, the idea here is that we're all kind of running this in kind of this race to learn data science. And for many of us, it's not going very well. So we all start kind of here. Most of us never graduate. The sad fact is most of us never kind of graduate out of this Dumb and Dumber trying to drive a moped. And I was like this too. So I get it. It took me like 5 years to feel comfortable with learning data science. But the goal is I want to get you here. And most of us, we don't start out learning so we can stay in this, state forever. We want to get here as fast as possible. It costs us a lot of money to stay in this state when we're trying to get jobs that need us to be in this state. So my goal is aligned with your interests. I want to get you to here. The key question, so we have a few questions we need to ask you. Do you know the tidyverse already? And the answer is, if yes, then you should take a look at my Learning Labs Pro program, which is what we've been talking about here. We've got a ton, and this is the roadmap for 2021, but we already have 50 labs. They're all based on intermediate topics that are going to be pretty important. Things like feature importance, variable importance, things like creating Shiny and connecting it up with APIs, things like production. And then you can see the topic list here that we've got. We're right now in this section here, this Tidymodels extension. So we're learning about these types of packages here. But we're going to be doing some other things like Spark, going Bayesian, working with some of the other optimization and simulation packages, targets, pipelines. We're going to be doing a lot more with time series as well. I have some plans here. And actually next week, we're going to be doing some time series with Microsoft's Light GBM, which is now in R, just happened here recently. So we'll be talking a lot about these topics that are super important to you. If you like these topics, join OL Pro. There is a caveat. You want to be at least a little bit comfortable with Tidyverse. Otherwise, you're going to feel like a fish out of water. So what if you're just a beginner, or what if you're interested in learning R and Shiny much deeper than what I go into in these tutorials? Well, I have a solution for that as well. It's called the R track. And the idea here is we all start at the beginning. And we've got this kind of system here called the R track that gets you prepped up and ready to learn data science and apply data science to your job. And there's a sequence that goes like this: do business projects, do analytics, learn through the R track, build production ready web apps, and then continue learning by taking the Learning Labs Pro courses. So everything you need is taken care of in our platform. Oh, well, what if you've already tried everything? I've already tried everything. Why is your program different? I get this all the time. I understand you're frustrated. I was frustrated. We're all frustrated because we're 12 months into whatever data science courses we're taking, and I haven't gotten any farther. I still don't know how to connect data science to the business. I don't even know how to code. I can maybe talk about machine learning, but I can't actually do it. Well, here's the solution. And here's why my program is different. Number one, it's integrated. I am not like other programs. I didn't just pull together a bunch of different instructors, have them record videos, and put them into something called an R track or a Python track. I didn't do that. I take a different approach. I, one instructor, have built the entire system from scratch based on my experiences and using my real data. So that way you learn based on what is needed in the real world. You're going to have to work with customers. You're going to have to work with products. You're going to have to work with all sorts of different information. You're going to have to do different things. You're going to have to do time series. You're going to have to do advanced machine learning. You're going to have to actually classify people as, whether or not they're going to churn. I show you how to do that based on the real world and what they're going to need. So a little bit about the R track. It starts with the 101 course. I get this question a lot. So how do I take the R track? Well, this is what I recommend. You take the 101 course first. It's integrated. You learn all of the foundations, your data cleaning, visualization, advanced algorithms, and reporting. Okay, you've now got the basics down. Are you ready for prime time? No, but you can at least start applying what you're learning to your job. To get to prime time, though, you need to learn my business consulting framework. This is, and we'll talk about this in a second, especially if you're interested in getting a job in data science, you need to learn this. The other one is time series. Every company has forecasting problems, and they cost their companies a lot of money because most of their forecasts are wrong. So you can walk in, immediate value is, I know how to forecast much better than what you're currently doing. That's a value add to you. That company is going to be more interested in you. Then you have the applications. So at the end, you have to be able to produce a product that, like what we saw here, which is something your company can utilize. That is what you need to learn in order to be able to take your results, what's in your head and what's on your paper and what's in your reports, and actually productionalize it with the company so they can use the results. Okay, so what makes your program different? Well, number two, it actually gets results. So, you know, if you're 12 months into your current program, I get it. You probably tried a lot of different stuff. You're frustrated. This is the proof, though. I have actual people who are using this using my courses to get them jobs. So, for example, this is Jennifer. She landed a VP of Strategic Analytics role with a prominent company. She used in her interviewing process the business science process framework or problem framework. And she also completed the project using R Markdown. These are two things that she learned in my courses. It doesn't stop there. Got a job, got a senior data science role, got 3 raises in 1 year, built one Shiny app in the first 3 months of taking courses, won the 2020 Shiny competition. All of these students, Masataki, Z, Mahana, Herb, Raj, these are all amazing success stories, but they can be just like you too. So the key is you have to take your first step, and this is the program that will help you get there. You just have to commit. So David is going to give you a special 15% off coupon, and that is valid until the next learning lab or until through the weekend. And what it'll be is 15% off the program, just as a thank you for attending the learning lab today, and also to get you kickstarted on the right track finally. So with that said, I'm here to answer any questions. Also, there's several payment plans too. I know that that's a question I always get is, what if I want to spread the payments out? There's payment plans. And there's also a Slack channel. That's another question I get. How do I get my questions answered? Well, I will actually answer them through our Slack program. I think that's it. So I'm ready to answer any questions that you guys might have for those that are still.
Yeah, awesome. There's been a lot of questions, and Max has done a great job at answering most of them. So
awesome.
Thanks for everyone for contributing to the conversation. And we're gonna keep the questions here short because we've already been on for quite a while, and I know some of you have very specific questions, and I don't know that we have enough time to dig deep into those. Really quick, just on the courses, I did put the link in the chat. If you're interested, check out the link. You can see the details of all the courses. One thing we tend to forget to mention is when you sign up for the course, you also get access to the Slack channel, which has all the data science students from business science in there. You can get help from other students, from Matt, and also you can interact with other data scientists. I think this is a nice question, a basic question, but a good one. So what's the difference between Tidyverse and Tidymodels?
So Tidymodels is, I guess, well, how I would classify it is a Tidyverse. Like if you go to tidyverse.org, and then there's tidymodels.org. So here's tidymodels.org, and then tidyverse.org. So tidyverse.org is these packages here, and what it really comprises of is like the stuff that you learn in the foundational course, which is the 101. It's your data wrangling, your basic visualization, your reading, you're working with text, working with tables, working with categorical data, tidying data, doing the pivot wider, pivot longer, and also iteration. So these are kind of like foundational tools. So if you look at like in the 101 course, the first thing you learn is those foundational tools. So that's the Tidyverse. And up here, we start to get into some data science algorithms. That's where Tidymodels comes into play. So this is tidymodels.org. And you can see you got Tidymodels, but like it's Parsnip, which is the machine learning libraries, R sampling. So when I did like the initial split and split the data up into randomly to 80%, that's R sample. But it does a lot more than that. Recipes, so like the pre-processing steps, those mainly reside in the recipes package. Tuning for hyperparameter tuning, and yardstick for the accuracy metrics. So like ROC, AUC, that came from the yardstick package. So that's basically the difference there.
Great. Ralph asks, do I need to take machine learning class before doing the time series?
So you should have the 101 down. That's the prerequisite for the time series course. That's what I recommend. If you don't know Tidymodels, you're probably going to be a little bit behind. So, and it may feel a little uncomfortable. So what he's talking about is this time series course. The 101 course is the prerequisite. So it's actually the prerequisite for all of these courses is the 101. You learn Tidymodels right up here. And that's where you get exposure to like XGBoost, random forests, and all of those algorithms.
Great. Okay, I think we're going to end it here, everyone. Really do appreciate you taking the time to join us today and sticking around to the end. I know it was long, but it was a lot of fun. We had a nice special guest today, and we had a couple of comments about having a Max T-shirt, and maybe we can get him on here full time. I think we'd probably have to kidnap him from our studio. But
yeah, I don't think we're going to be able to pull him away from our studio from the way he was talking about him. So
yeah, exactly. But yeah, it was a lot of fun, and we really do appreciate. Again, I know I've said it, but we really do thank you for spending time with us here, because we put a lot of effort into doing these. We enjoy interacting with the community. So to have you guys come and interact with us is a lot of fun. So thank you.
Yeah, I really appreciate it. And thanks so much. Tune in a couple of weeks. What we're going to be doing is the next one in the series. We're going to be talking about Light GBM. So if you're interested in that, it won the M5 competition, which is a forecasting competition. And I'm going to show how to integrate it into Model Time. So check us out.
Sounds good. Take care, everybody.
All right. See you guys. Bye-bye.